Now we are in lesson 4.3, differentiation rules. Already we did in 4.2 the definition of the derivative. Now we're gonna have the formulas. So I will use the notation f prime, but when you see f prime of x, it means also I'm doing dy over dx, because you know that f of x, it means it's y. So if I have the sum of two functions, the derivative of the sum is the sum of the derivative. So if I have f of x equal ux plus vx, it means the derivative is u prime x plus v prime x. You'll see it in the example what I mean by this. The derivative of a constant is 0. And if I have an exponent, so if f of x equal to xn, its derivative is n xn minus 1. In this example, I'm summarizing those three properties here. When I say the sum, it means I'll do the derivative of 3x to 3, and then 4x squared, and then 2x, and then 1. So what is the derivative of 3x? 3, so I'm using this property here, so it's gonna be, so the exponent gonna go down, so 3 times 3, 9, and then 3 minus 1, it's 2, so it's 9x squared, plus 2 times 4, 8x1, minus, here the exponent is 1, 1 times 2, it's minus 2, and then 1 minus 1, 0. Any number exponent 0 gives me 1, and this is a constant, the derivative of 1 is 0. So in this example, as I'm summarizing those three properties here, let's move to more example. If I have, for example, the radical, in some books there is a formula for the radical, but also for the radical, you can use the exponent rule. When I say radical, it means it's exponent 1 over 2. Guys, if it was, for example, radical cube x, sorry for the handwriting, it's x exponent 1 over 3. So it's the exponent here over the number here. And then again, I will use exactly the formula that I was using for xn. So it's going to be half x, half minus 1, it's minus half. I don't like to keep at all negative exponents. So it's going to be half times 1 over x. Half, it means 1 over 2 radical x. If I have a quotient, u over v, the formula is u prime v plus v prime u over u prime v minus v prime u, sorry guys, over v squared. So, and then I have u is equal x3 plus 2x, so it's going to be u prime, it's 3x squared plus 2. V is equal to x, so v prime is equal to 2. And then now, sorry guys, and then I'll use the formula, so u prime v minus v prime u, so I have the minus here, I wrote it wrong there, I'm sorry. So this one times this one minus this one times this one, and then you develop, and then after you develop, I factorized here by 2x, and then I simplified and I got the answer to x squared minus 1 over 2x. More formulas, u times v, if I have a product, it's u prime v plus v prime u. It's an example. Some of you will think about, okay, Miss, why I don't distribute and then I go back to the normal formula. You can do that. I can distribute. But if it was here exponent 4, exponent 5, it's hard to distribute it. Also, I can use the formula. U, it's x squared plus 3. U prime is 2x. V is x minus 4x plus, so V prime gonna be minus 4x plus 1. And then I also use the formula U prime V plus V prime U. Then you can develop and continue your final answer. What I really care about is now the chain rule. And this is very important. If I have an expression with an exponent, example here I have 2x squared plus 3 exponent 5. Here I need to use the chain rule. I have two different chain rules. I have one as when I change the variable and the other one as a composite function. I like this one more, but I'll give you the two chain rules method. So first of all, I will take that this expression, I will name it u. So it's u exponent 5. So what is the derivative of y with respect to x? It's dy over du times du over dx. Guys, as I'm simplifying here, so it's dy over du times du over dx. What does it mean dy over du? What is the derivative of y with respect to u? So in this case, I look at this one here, u5. So when I say u5, it means it's 5, u4, it's as it is x5 times du over dx. Now I look at u here. What is the derivative of u with respect to x? It's 4x. And then I replace back u by its expression. So it's going to be 5 times 2x squared plus b exponent 4 times 4x. And then you end up by multiplying 4x times 5, and I will have the answer 20x times 2x squared plus 3 exponent 4. So this method, we call it the chain rule. So every time you have an expression with an exponent, we change the variable. We write instead of the expression u, and then we use the chain rule. So we divide the derivative in two parts, derivative with respect to u times u over dx. Now the second chain rule, it's the composite function. So I can also use the composite function. So I can write the given as two composite functions. So I'll give you first the formulas. When I say f round g of x prime, so it's g prime of x times f prime of g of x. Let's give you an example. Here you can see I have a radical and I have an expression under the radical. So method one, you can write it as an exponent and go back to the first chain rule and you have and do the same. It's dy over du times g over dx. Or I can use the composite function. I can see here two functions. I have the first one, it's radical. So I will take f of x equal to radical x, and g of x is the expression under the radical. If you do now f round g at fog, you know it from chapter 2, f of g of x means instead of x and f, I put g of x, I'll get the same answer that I want here. And then I just use the formula. What is the formula? It's g prime times f prime of g of x. Okay, let's do the g prime of x. This is g of x. What is g prime of x? It's minus 6x. Excellent. F prime of g of x, so I need to do first f prime of x. F prime of x means I want to do the derivative of x exponent half. That's why we did it in the first page. So it gives me the answer 1 over 2 radical x. Now I need to calculate f prime of g of x. So instead of x here, I need to place it by g of x. So it will be 1 over 2 radical 4 minus 3x squared. So this is g prime, this is f prime, this is f prime of g of x, and all what we need to do now is to multiply to get the final answer. This is g prime of x times f prime of g of x, and this is the final answer for the derivative. So either you can use the chain rule by changing the variable as u, or by using the composite function. Let's move to the last part in this lesson. It's the higher derivative order. So when I say f prime, it means dy over dx. I can do double, f double. I can write it d squared y over dx. I can and write 3. It's d 3y over dx. So if it's f n of x, I can write it dny over dx. Okay, now this is an example. This is a function. The first derivative is 12x squared plus 4x plus 4. The second derivative is 24x plus 4. And the third derivative is 24. If I want to do f to the fourth derivative, it's going to be 0. And all the other derivatives are 0. That's it for this lesson. We'll do more application in the class. Watch what the video, guys. Take notes and see you next time in the second video.